Today's lesson is about squares and square roots. It'll be a two-part lesson. The first part will be on perfect squares. We will begin with a problem involving our friends Mayhem and Haas. Mayhem and Haas are concerned about all the chemicals being used in processed foods, so they want to make their own garden. Mayhem wants the garden to be a perfect square, and Haas knows they'll require a minimum area of 196 square meters to grow corn. They will need to put up a fence to keep their dog Roy Boy from digging up the plants. What is the minimal amount of fencing they'll require to accommodate all their needs? Let's start with what you know about a square. First, a square has 4 equal sides. A square also has 4 equal angles. Do you remember the measure of each angle? Each angle measures 90 degrees. Next, we'll find the area of a square. You may recall the area of a rectangle is length times width, and that is given in math terms in the formula A equals L times W. What adjustments do we need to make to this formula to accommodate the area of a square? Well, a square has 4 equal sides, so the length would be the same as the width. Therefore, we could think of the area of a square as being width times width, or in math terms, as A equals W times W. The area of a square could just as easily be given by length times length, but we'll stick with our formula A equals W times W for now. W times W can also be written as A equals W with the exponent of 2. Now in math, anything with the exponent of 2 can be said to be squared. So our formula becomes A equals W squared. Now let's calculate the area of our first square. The width of our first square is 1 centimeter. So the area would be 1 times 1, or 1 squared, which gives us 1 centimeter squared. This is a unit measure, so what I'd like you to try to do before you calculate the other areas is to picture how many of these 1 centimeter squares will fit inside the other squares and estimate what the answer should be. I'll show you what I mean on the second square with a width of 2 centimeters. There's 1, 2, 3, 4 1 centimeter squares would fit inside. Now we're ready to calculate the other areas. As with any online video, please feel free to pause the recording at any time to take notes and attempt the questions. So our second square, again, has 4 1 centimeter squares that would fit inside. And this is confirmed by our formula. A equals 2 times 2, or 2 squared, which is 4 square centimeters. In our third square, we would have 9 1 centimeter squares that would fit inside. And our formula confirms this. Area would equal 3 times 3, or 3 squared, which is 9 square centimeters. Finally, our last square would accommodate 16 1 centimeter squares, and our formula would read A equals 4 times 4, or 4 squared, which is 16 square centimeters. The answer to these 4 questions of finding the area of these first 4 squares, 1, 4, 9, and 16, are called perfect square numbers. If we were to continue this pattern using larger and larger squares, what would be the next 6 perfect squares? See if you can figure out what they would be. Did you find them all? Notice in the column to the left, it shows an easy way to make perfect squares. All we do is to square the next whole number. So we had our first perfect squares, 1, 4, 9, and 16. The next one would simply be 5 squared. 5 times 5 is 25. 6 squared, 6 times 6 is 36, and so on. You could find as many perfect squares as you wanted. It would also be interesting to think what would happen if we squared a fraction or a decimal. Over the next few years, you will hear a lot about perfect squares in math and science, so it'd be a very good idea to memorize the first 20 of them or so.